Yo, what is going on, hackers? How we doing? Some of the Discord asked me when the ricing video for Obsidian's coming out. Eventually. Eventually. Probably next week. I'll probably record it sometime this week officially. And I should be able to push it out next week. Hey bro, hey man, hey, let's go. How we doing? Good, good. Everything's going good. Today we're doing some malware development. Finally, I have my home server for the most part all set up from last stream. I actually, here I'll show you guys a quick update from the progress that we made. So last stream, right? If I actually go ahead and connect to my home server, you'll notice that it looks the exact same as soon as you can see. Like, this is my home server. If I list, like, you can see I have all my files here, even my Vim. It got transferred over. Basically, instead of using NixVim, I just went back to a normal init.lua file, and that was kind of what we needed to do. So shout out, I don't remember who it was from last stream who recommended just going back to init.lua, but whoever that was, appreciate the recommendation. I think this is better anyway because I can use this same config across different machines rather than only being stuck to NixOS. The good news is we also got some other stuff working between here, right? So file syncing now works. So if I go into my Nix directory, and this is on my main computer right here, and let's say I just touch a hi.txt. Now, basically, I have syncing set up between the two computers. So not only will it be created on this computer, but if we go back over to my home server and I list next, you'll see hi.txt right there. So everything syncs between computers and all this other stuff. So I'm happy. We can get rid of that hi.txt. We don't need it. What we are going to be doing today is some malware development. So today I wanted to play around with the idea of port knocking. I don't know if you guys have heard about port knocking. Do something else. We are getting bored. If you guys haven't seen that clip from last year, that was so funny. I'll put a link into it in a little bit. But yeah, today we're going to be doing some, port knocking. So port knocking is basically a tactic where you have a computer that is trying to talk to a different computer, right? I'm assuming that the target machine is infected. And by making connections to a certain series of ports, you can basically tell the computer that, hey, you're trying to connect to it, and the target computer will be like, okay, I'll establish a connection. So it's kind of like a secretive way of talking to each other. Maybe I didn't describe that well enough. Maybe I need to draw it out for you guys. Yeah, maybe I could do that. Let me see if I go on like Obsidian, maybe. Actually, here, let me do this real quick. I want you guys seeing all my video ideas. Going to steal them from me or something. Close. Okay, let me see. Do we have a skeleton? All right, cool. Let me do this. Cool. So let's draw this out. This is going to be really bad, by the way. How do we do dark mode? First of all, that's the most important thing. Dark mode. Oh, okay, there you go. That's better. Okay. So if we draw a box here, and let's draw another box here. Wow. Okay. So this is, let's say this is the attacker, right? And this is the target. Okay. Cool. Basically, the target machine can have a series of ports enabled on it. Let's say port 1337, port 1338, and then port 1339 are all open on the target machine ports. People keep talking about my beard. I've had this beard for a long time. I guess I haven't been on camera in most of my videos as of lately. Like, I've been using that wave thing, like that voice, like synthesizer. So you guys actually haven't seen me in a little bit. But appreciate it. I do appreciate it. It's just funny. let's stay consistent here. Ports. All right. So this target machine, let's say all these ports, they can be closed, they can be open. It doesn't really matter, right? Actually, they're probably not going to be open. Just not open, right? But the target is going to be listening. Okay, cool. So then finally, when we go ahead and we connect to, let's say, port 1337, right? And then we're going to try to make another connection. And then we'll do 1338. Oops. And then we'll make another connection, right? And this will be 1339, just for the example. Basically, after we hit up those 3 ports, it'll be done listening, be like, oh, okay, cool. I'll connect back to you. And then connection. Okay, does that kind of make sense what port knocking is, right? Like there's a target machine that we have malware on, and it's listening for hits on these series of ports. And once we knock out those ports, it'll be like, okay, cool, we can connect. It's kind of like a secretive way of having, you know, an established connection between computers. So that's the goal. That is the goal. And I'll put it in the chat what we're actually doing today. Today we are building malware that uses the port knocking TTP. Okay, and I'm going to pin that. Someone recommended to start pinning things in the streams. I'm gonna need a fit check. What's up, sis Jam? How you doing? Good to hear from you, man. Okay, cool. Well, yeah, I was outside earlier today. All right, word. So I'm assuming that you guys are kind of understanding what this whole thing is. So I'll just do port knocking .escalate draw. Okay, cool. All right, well, I'll leave this up here in case we need to explain what we're doing again to people down the road. But until then, let's go ahead and start development. Now, I'm going to try something a little bit different. Let me go back to my screen. I'm going to try something a little bit different. I'm going to try to use SSHFS when building this out. I just want to see how well my my home development is for something like C Windows. I could just stay on one machine rather than having to fly between the virtual machine and stuff. So we're going to try it. We're going to give it a shot. If it doesn't work out, it doesn't work out. So that's what the first series of events is. Okay, so I want to go to development. Doing good, brother. How are you? I'm good, man. I'm blessed. Absolutely blessed. Networking. Okay, and then we should have SSH somewhere. Persistent SSH. Okay, let's take a look in here. All right, networking. Persistent SSH. Okay, yeah, and then we remove capability, blah, blah, blah. Okay. Okay, yeah. So here's the thing. We aren't opening the ports. They are not open. What the hell? What the hell just happened? Okay. Bro, why can't I edit this? This is so weird. I just want to change the colors. Hello? All right, yeah, let me like bold that, or like change that color. Can I make that red? I don't know. Okay. But yeah, basically the ports aren't open. Like they're closed, but we can still see when ports are being hit, right? So our malware is basically going to see like if those ports are being hit, we can establish the connection. It's on 443. I mean, yeah. I mean, like if you just did your traffic over HTTP and stuff, like it's better, but like even still you're reaching out to I don't know, like a specific web server or something. Maybe it's blocked by the DNS or something like that. It's just a technique that I've heard of, but I've never actually implemented before. So I guess if it isn't practical, then it's for a learning experience. And if it is practical, then I developed something practical. So it's a win-win in my eyes. All right. So I think that should be fine. We can just probably run that. Go into dev, cd into networking, and then / persistent SSH. Okay. Requires elevation. Oh, do I need admin? How do you get an admin? Do I have to right click? Bro, I just need an admin. I just need an admin PowerShell, dude. Hello. How do you open? Can you open one as an administrator? Settings. Okay, maybe Windows Terminal is not built for this, or I'm just stupid. So that could also be a factor here. PowerShell. Okay, run as administrator. Okay, UAC, yes. Ugh, look how ugly PowerShell is. Oh my gosh. Wait, no. I do recognize you, Adam. Holy crap. No way. Daniel? Yeah, I do remember you. Wow. Long time no see. Sister, nice call. I didn't recognize the name until you brought it up. Wow, dude. Oh, whoops. This is the wrong directory. All right, cool. Clear cd into users, Cosmo, development, networking. All right. Let's try this. Wow, that was a crazy cache system. Oh my gosh, yeah. All right, we're just gonna let this run and let's see if this works. Let me actually see what my IP address is. Where is it? NIC. Okay, 122.163. Service created. I'm just gonna wait for it to finish. What kind of persistence does your script do? SSH. It's just like permanently enables it. So on every, so on restart, it'll recognize it. Okay, so that means if we go over here and we SSH into Cosmo at 192.168, and I forgot the IP address already. 122.163. Okay. 122.163. Yes. Oh, all right, cool. Oh, wait, we're not on PowerShell. PowerShell. There you go. So I can list and stuff. Whoops. Oh my gosh. There you go. Okay. Cool. So we have SSH. That means we can use SSH file system, right? So let's go into my development directory. Let's just make their Windows 10. Cool. CD into window. Oh no, CD into / Windows 10. Okay. And we should be able to, let's go into 220, cat connect.py. All right, cool. CD into window. Okay. Actually, I'm gonna make their machines move Windows 10 into machines, CD into machines. All right, cool. And then we'll do v Windows 10.sh. Cool. And then yeah, so instead of pi, we're doing Cosmo at SSH. All right, yeah, we want this. Yeah. So let's do this. Okay. And then instead of /home that whatever, it should be users Cosmo and then development. User bin and bash, and then that should be it. So if we, that's our chmod plus x Windows, oh bruh, Windows 10.sh. We don't want the directory to have Windows or executable permissions. It's fine. Trying to keep up with cyber until I took a break. Currently working on as a full stack developer. Oh, nice. Always liked web stuff. Yeah, you are a better man than me. I've never been able to truly love web stuff. We don't have SSHFS. No mount points specified. Oh, whoops. Quit. All right, we're going to move this SH to connect.sh. All right, cool. V connect.sh. There is supposed to be a mount point. Is there? Windows 10. Okay. So I'm actually going to close this. All right, so if we cd into next, and then let's go out a little bit. Let's do packages. What packages would this go into? Utilities. Wait, I have SSHFS right there. What? Am I tripping? Flake. Yeah, packages, utilities for Planet Cosmo, packages, utilities. Am I tripping? Maybe the command just didn't work. Oh, what? What? The command, okay, I don't know what's happening. I don't know. I don't know what's happening. I don't know why that didn't work. C into dev, C into, oh, wait. I was on my home server. Okay, hold on. C into dev, C into, wait, SSHFS. Okay, yeah. Seeding into machines. That's con. So if I seed into Windows 10. Okay, cool. So I have all of my Windows file here. Nice. I know there's a lot of elitism in those areas. Oh wait, I missed I'm a second year comp sci student, growing interest in cyber, mostly low level stuff. Like binary exploitation, kernel stuff, networking. Will I still be able to find jobs? I think so. Yeah, low level stuff is pretty important. It's a harder skill to acquire. All right, cool. Which means now I can edit my files on the Windows machine over SSH. Okay, so just as a test, let's see if I close all this stuff. If I go in development, I should be able to touch hi.txt and it should appear right there. All right, perfect. So we did mount our file system. All right, cool. So that means we can work on Windows code over here if we want to. Yeah. All right. So let's actually get started with the project stuff. So I'm going to make a new, I guess, tab or pane over here. And this will be where we're developing the server stuff. Okay. So now that that's all done and dusted, let's kind of see how port knocking actually works. Let me go on GitHub, just port knocking. Simple Python port knocking client. No, I want to do it in C. I mean, we could just ask chat, but I kind of want to like learn how to do it. You know what I'm saying? Like, how do you? Okay, let's just start somewhere basic. In C on Windows, how do we listen for a connection for an attempted connection to a port in C on Windows? You can use WinSock. Okay. Jeez, this is a lot of stuff. Well, I don't want to accept the connection. I just want to recognize. I don't want to accept the connection. I just want to recognize if the port is being hit or not. Right. Okay. So in here, let's go into networking. We'll make their port knocking. Seeing the port knocking. Okay. We'll call this listener. Let's see. Actually, yeah, fuck, listener, let's see. V, listen. Let's see. There you go. I'm lazy, listener, port knocking, listener. I hope it works out because my mom would kill me if it didn't. It's funny. All right, so if I actually, can I include like, what happens if I include Windows? Like, is that, yeah, it's not going to be recognized over SSH stuff. Maybe I should just do it over here then, you know? Maybe that was pointless. How do you show your projects and help the people rate it? There's some projects I've made. Need some opinions. I mean, you can always send them my way. My DMs are open. Okay, is that font too small for you guys? Probably. let's do like let's do 20. Okay, yeah, I'll stick with 20 for now, but let me know how that is. All right, cool. So right. Anyway. So I don't like how it does this stuff. I'm not using C. Like, what's the C? What version of C do you have to declare variables before? It's the one before C99. It's like C83 or something. All right, so cool. I'm gonna hit you up, Cosmo. Good, you got a platform preference. Probably Discord. Yeah, my Discord's. You can hit me up on Discord. Okay, so what's this doing? Did we say startup? I actually haven't used Win API for sockets, so this is new to me. Did we say startup? Okay. We say startup initializes the WinSock. Yeah, makes sense. Okay. WinSock A. Right. So that's initializing WinSock. Then we create our socket, right? AFNet sock stream makes sense because there's that IPv4 and then TCP, and then I don't remember what 0 is. Okay. Then you bind the socket to a port. Interesting. Okay, so after we bind it to a port, we do our socket bind. And then we do a typecast of a struct to the server adder. Okay. Oh, we typecast it to a pointer. Gotcha. And that equals socket error. Okay, so if there's an error, then we start listening for these socket connections. Okay. So now that it's listening, it's going to do a while true. So what's this stuff doing? FD0 setup select to monitor connection attempts. Activity select, blah, blah, blah. If activity equals socket error, connection attempt detected. What if we are listening to a series of ports in a certain order, i.e. 1337, 1338, 1339. What am I trying to do? I can't pin it for some reason. Okay, yeah. What I'm trying to do is port knocking stuff. So we have an attacker computer and we have a target that we have compromised, and we want to be able to basically hit a series of ports to kind of almost like a password, if you will, to enable the connection. So like even if we don't want it to reach out back to us immediately, we can, from the attacker machine, kind of enable its connection by having it listen to it hit a series of ports. That's kind of the port knocking is what it's called. Need to leave. All good. Catch you. Okay. So how are we gonna? I mean, I don't want to just copy and paste the freaking ChatGPT stuff. I hate when it makes me choose. Just tell me how to do it. I don't care. Just pick one for me. Sure, this one. I don't really care. Okay, let's see if we can actually figure out how this is going. Okay, so it does the array of ports. So how does it actually can add that port? Port I, is it looping right now? Oh, it is looping. So for each port. Okay. That's pretty cool. Okay, so let's take the time to actually learn how this is working. Got you. All right. I don't want to just. All right, we'll copy it over. But we're not just gonna like blindly copy. We're gonna learn as we go. Okay. Already has standard IO and then WinSock. Okay, cool. So ports count 3. How many times do we use this? Ports count. Hello / ports count. I see. Okay. Hacking NSA today? Yeah, that's exactly what we're doing. All right. Timeout in seconds. All right. Yeah. So this is our array of ports. WS data equals WSA. Yeah. I don't like programming in C like this. You guys say what you want, but the C standard of C99 means you don't have to actually declare all your variables at the top. So that's not, I'm not going to do that. To each their own. To each their own. WSA. Okay, so we do need this one. And oh wait, hold up. We don't have relative line numbers. Can we set that up? Line numbers relative. Okay. That's better. Okay. 12 down. Alright, so we do our WSA. I want to finish the libcosmodium CS project because I would love to build that. I have bad habits to use ChatGPT for every programming. It's hard because like it's hard for ChatGPT to help you when it just writes the entire thing for you, you know. So like with this, because I haven't done WinSocket stuff before. I'm just kind of using it to learn. Don't you need some multiplexing? Enlighten me. Oh, so there's a get last error specifically for WinSockets. That's actually cool. I think would get last error still work or I don't know. Okay. And then here we do exit failure. I mean, if you open so many connections, WinSockets, you might need some threading. Oh, that's what you mean. Maybe. If you want to work in parallel. Yeah, okay. No, I was thinking of hitting them in series, at least at first, kind of like a combination, if you will. UTC, okay. Okay, let me see if WinSocket tutorial, because I don't feel like I'm learning right now. Like I want to getting started with WinSocket. Okay, let's look at the applications. What about 011? Hey, Abby. We can see a process running on 437 by running netstat. Okay, no. You guys are missing the ports are closed. The 1337, 1338, and 1339 are not open. Not open. Oops. Okay, what the heck just happened to this freaking... Why did the window get so small? Okay, anyway. Yeah, they are not open. But you can see when a service is attempting to hit a port, even if the port is closed, the system will just tell you that the port is closed. But on the software level, we can still see the port getting hit. So these ports are not open. But we're just listening for attempted connections. Does that make sense? In fact, I don't think this socket thing is doing... I think this socket stuff will actually open a port. Still listening for connections on that port. So that's when that's that. Maybe you're right. Maybe you're right. Let me see how other people have done it. Because I haven't done port knocking before. This is something I heard about, and I was like, oh, let me play with this idea. Sounds cool. Okay. See, it says, okay. Okay, this is a lot. Host name, enter remote host name or IP. Max host name. Okay, this is like giving me a headache trying to read this. Air connection made a port. Maybe you are right. I don't know. Close socket. Because it is making a socket. You are going to have to listen to the port. Yeah. So what's the point of port knocking? Am I tripping? Port. Explain the malware TTP of port knocking. Port knocking is a stealth technique used in malware, backdoors, and adversaries to conceal open ports and control remote systems without triggering network security alerts. Yeah. Yes, exactly. The ports are closed by default. That's what I thought. The attacker sends specially crafted packets. Huh. And then it will actually open the port for the connection. Yeah. Okay, yeah. Can you build a port knocking proof of concept client for Windows in C. See, that's what I thought. Yeah, the ports are supposed to be concealed. So I'm not tripping. Target IP for sure. Okay. So it creates the WinSock. Creates the socket. Wait, it does add the port. Okay, knocking on port. Oh no, this is the one that sends the, yeah, this is the one that's knocking. No, make the one to receive the knocks. Oh, so this is considered the server? That's not how my brain put it, but I guess that makes sense. Listening for knocks. Okay. Oh, sorry guys. Okay. Improvements on the real backdoor. It would enable some sort of connection, blah, blah, blah. It would modify the system action. It would encrypt the sequences. Okay. So would this be... So basically a malware that constantly monitors a port, and if the port is messed with, it reports to you, or does it monitor the traffic and report that to you? Neither. It's more of like it's a technique to initialize a connection. Let's say you install this like malware on the target machine, right? But it hasn't made the initial connection to your attacker C2 or your framework or whatever you got going on. So what you can do from the attacker side is hit, let's say 13, 37, 38, and 39, and the target will see that those ports were messed with, and then because it recognizes that, will then establish the connection to you. It's almost like a combination lock or something. But I'm gonna ask you a question. Would this be detectable via netstat? Like, would you see those ports open? Yes, but only under specific conditions. Ports are in a listen state. Since the server binds a listening request sequence, they will appear in netstat. Okay. This can expose a presence of a listening service. A stealthier approach is using reuse address with bind. So instead of keeping ports permanently open, the server can bind temporarily and close the socket after a knock, and only rebind when needed. This avoids the port being constantly visible. Using raw sockets. Raw socket. Using raw sockets, which is undetectable by netstat. Instead of listening, malware can use raw sockets. So select that raw to sniff for connection attempts without binding to a port. This prevents ports from appearing in netstat while still detecting knocks. Huh. This requires system privilege or admin privileges. Oh, I see. I kind of want to play with this idea though. That's what you meant. Because you bind to, yeah, no, I see what you're saying. No, for sure. using UDP port knocking is stealthier. UDP ports don't appear as listening, only in use when actively receiving data. I kind of want to check out that sock raw stuff. I'll write that down for later. Raw sockets. But it seems like that it does require admin. So I'm not gonna, unless we have like a privesc vector. Or I mean, like if it's running as the user, then maybe if the user has admin perms, but let's try UDP. Maybe UDP will be the way to go. Because my understanding, my understanding of port knocking was that like the sockets or the ports weren't open. Like when you do an mmap scan and you hit a port and the port's down, but like it's still noted in like the network logs that port was hit. You know what I'm saying? So my understanding of port knocking is that like the attacker could hit those ports and you don't necessarily have to listen to them, but you could attempt to detect them or recognize them or whatever. So or just don't use crazy random ports like 1337. Maybe you can listen for a specific packet on 443, like a custom protocol. Okay, yeah, that's actually not a bad idea. Build your own custom protocol. Okay. Okay, let's get back to this. We can either, okay, maybe building a custom protocol would be cool. Right now, you guys need to understand, like, I'm not trying to build, like, I'm trying to understand and learn about this technique, because I heard about it. I'm not trying to, like, build the full-fledged tool, at least not yet. But I like the idea of the custom protocol. It's pretty easy to do with UDP too. Maybe UDP will be the way to go. All right, let's try UDP. Yeah, we did not make a crazy EDR bypass. No, you're good. You're good. It was funny. No, but I like you're bringing up a lot of good points. Especially, I didn't consider the issue about actually listening to the ports. But this should avoid detection for something like netstat or anything like that. What's a bypass? It's like a method of getting around a security feature. All right, let's just blindly copy and paste this. we will modify it shortly, I promise, guys. It's just one thing at a time. Okay, I think, oh yeah, we have center IO. We already have that. Okay. So, assuming that it's 1337, 2020, or quad 2, and then 8080. Just for simplicity, we're just going to do like, 1338, and then 1339. Okay, so this is the function where we're listening to knocks. So we have our WinSocket, blah, 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 blah. Stealthy UDP port knocking. Okay. Let's just try to see if this works first, and then I'll take the time to actually learn what we're doing. C2 dev C2 networking. We have GCC, right? GCC listener.c tech o listener. Okay, we got a warning. Oh no, we got a we got error. Oh, do we have to do a tech L WinSocket or something? What are we using? Yeah, please include WinSock 2.h before Windows. Okay, I didn't even realize that mattered. Okay. Yeah, we need tech L. What do we need tech L of? Yeah, is it WinSock 2 or something? How to compile? I just don't know what library. NodeSec, what's up, NodeSec? How you doing, man? Do you see? Okay, yeah, that's the tech L, WS232. Oh, dude, that was literally in the pragma. What am I doing? Lacking, y'all. Tech L. I'll explain what we're doing in a second. Port knocking. Actually, that's what we're doing. Port knocking. Was there not a space? What'd I do? Oh, tech L. Oh, I see. I had two L's. Double L. There you go. Okay, cool. So if we run the listener.exe, sure, dude, sure. Okay, so it's looking for UDP ports knocks on 1337, 38, and 39. Okay, so do we have mmap? We do. Okay, so mmap. How do you do UDP? Tech SU. So nmap. Bro, excuse me. nmap. Tech SU. Tech port 1337 on the target machine, which is 192.168. I remember the IP address. 122.163. Okay. That 122.163. You requested a scan type, which requires root privileges, sudo. Okay, we hit it. So does it recognize? Oh, detect a UDP knock. No way. That is so cool. That is sick. Hold up. Let me put this on the, how do I put this on the left side? Okay. That's cool. I also want to make sure that we aren't like, so right, we want to make sure that this actually isn't being detected by a netstat. Isn't it like tech AH or something? No? Or is it AN? I don't remember. AN. There you go. Actually, well, let me not. Yeah. I probably shouldn't run that, but it's okay. I don't really care. Here, let me do this. Okay, yeah, it's not in the net stat. Perfect. Okay, so yeah, that does work. All right, so now I want to actually understand how this is working. So hold on, first of all, let me add UDP port knocker. Okay, yeah, so that's sick. That's so cool. Actually, let's finish it too. Like if we do 1337, and then we should be able to do 1338, and then let's go to 1339. Right, on the Windows side, if we check the terminal, yeah, so it recognized the knock, and then current knock execution, blah, blah, blah. I don't think we actually have it do anything for the execution, do we? Yeah, no, we don't have it do anything. That is so cool. Okay, so yeah, okay, well, thank you, chat. Let's see if we can actually figure out how this is working now, because I just want to like learn something here. I don't just blindly chat it, you know what I'm saying? Okay, so we have a macro for the number of ports here. Then we have our knock sequence. Then this is our actual listener. So let me actually write this in a way that I will know how to read it. Yeah, okay. I'm just gonna, hello? Okay. So this is how you start up. Like, yeah, let me look at if there's actually any like good, yeah, getting started. That is cool though. The UDP is sick. Let's start tutorial programming and see. So yeah, it just looks like this is pretty standard, you know. Creating the socket. Interesting, it does S equals socket in the if statement. I've not been active in the community a good while. Did you not like go to Army boot camp or something? I thought you even learned assembly while you had to write your shell code. Yeah. Basically, I'm at the academy now, the Naval Academy. That year I spent pretty much was like it's like an army school to kind of prepare you for the academy. But yeah, I've been doing a lot of stuff. I've been doing like cyber warfare trainings and stuff like that in my time here since. And yeah, we've been learning like assembly. We've learned bioexploitation, lots of C stuff. I'm a computer science major while I'm here. And then, yeah, hopefully we'll do some cyber stuff when I get out there. Yo, what's up? Yo, what's up, man? How you doing? Okay, yeah, let's see. Let's at least pretend like I wrote this code. The Academy. Oh, you're not American. The Naval Academy. It's like a military service academy. So creation failed. d2 percent sign, d2 percent sign. Okay, so this creates the UDP socket to listen to all ports. So we do our sock equals AFNet sock at dgram. So yeah, IPv4, and then we're using UDP. What's the 0 right here? I forgot. Is it like if I man socket, will it show up? Man socket. Man sockets. All right. What is it called? Socket docs. Am I tripping? Oh, this is Python, but it should be the same. Let me just ask chat. Like, what am I doing? What am I doing? Let me just ask ChatGPT. It's the protocol, you think? Well, no. The second one's the protocol. That's UDP. What's that 0 for? Oh, it is the protocol parameter. You're right, yeah. But what's the point of sock dgram if you're also saying that's UDP? Huh. Oh, instead of 0, you could write IP protocol UDP. Interesting. So what would you use for TCP? So it's probably 1. That's what it is, right? IP proto. Wait, what? Why is it also 0? The second is the file type. Or is the second is the type of socket. Okay, so it's the type of socket and the type of protocol. So for use IP proto, so you can use 0 for both. Okay, got you. You can go see on the Microsoft Docs, yeah. All right, socket Windows. Oh yeah, that's way better. Thank you. Windows documentation, man. Something about it. Got you. Protocol. Yeah. So for protocol. Interesting. Wait, but for IP proto it says 17 for UDP. And for TCP it says 6. Explain this, chat. Explain this. Yeah, that made no sense. I didn't think it could be 0 for both. Question, did you learn... Did you self-learn all of this, or did you follow some course? I mean, this was chat. This was ChatGPT right here. But in terms of my actual, like, development skills, yeah, mostly self-learning. I mean, there's, like, online courses that teach you how to program in C, you know? But you can also, I mean, you have, this is, like, the most access you've probably ever had to information, so... If you really want to learn something, you can definitely learn it. I mean, you have ChatGPT, you have YouTube, you have my YouTube channel, you have other YouTube channels, you have like all of Google, you know. So, and I feel like there's there's a huge access to information that if you're trying to learn something, isn't too difficult to get into learning it. So if I use the actual UDP one, let me just do IP Proto UDP. Let me put that in there. Let me see if that changes anything, which I doubt it will. So yeah, if we do this, and then let's cancel this, and then hello, there you go, and listener.exe. Oh, this isn't bash, freak. How do you how do you do the and thing in PowerShell? Isn't it like semicolon or something? Okay, that just completely broke it. Undeclared identifier. Okay, what happens if I put 17 in there? Huh. But if I put 0, it works? Oh no, it's actually complaining regardless. Oh, I'm so stupid. I still have my stuff commented out. What am I talking about? I was like, oh, why is this not working? It's like, because all your stuff is, all the freaking variables are commented out, dude. What are you talking about? Okay, so that means I could do IP Proto then. Why is there no, isn't it IP Proto UDP? Isn't that what the doc said? IP Proto underscore UDP, yeah. Bro, sometimes, bro, my brain just does not work. So yeah, that does work. IP Proto UDP. And 17. Let me ask chat about that. Let me see if chat was wrong. So, what's the point in these? Explicitly defines the protocol number. Multi-protocol socket. Okay, is that what, does it talk about that? It's where's the socket function? Yeah. Protocol to be used, blah, 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 and blah, 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 on Windows and blah, 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 IP Proto, blah, blah, blah. If a value is 0 specified, the caller does not wish to specify a protocol, and the serviceful provider will choose the protocol to use. Okay, so 0 will choose the protocol, but if you want to explicitly state what type of protocol is going to be used, you can, okay, got you. Okay, cool. You know, sometimes if you just read the documentation, it just makes everything so clear, you know? Got you. Okay. So yeah, if that's the case, I'm going to explicitly specify IP Proto, so I know it will use IP Proto. Okay. Now it's going to bind the socket to all available interfaces. And then listening for UDP port knocks on those three numbers. Not sequence 0, 1, and 2. While 1. So it's going to each bind to each port. And then if bind, blah, blah, blah. Bind failed. All right, so this is if it doesn't work out. We'll do, oops. Well, for listening, I like to use asterisks. Let me go here. Okay, so bind failed. It's an error right here. Get last error, and then it's going to close. WSA cleanup. Okay, and then wait for UDP packet. So if received from the sock buffer, blah blah blah. So detect the UDP packet on the port knock. And if the secret index equals the correct number of ports. Out, all good. I'll see you, Berserk. Oh, that's really cool. I didn't realize that this was all right, let's just do something simple then. So close socket, blah blah blah. So yeah, after it resets the sequence, basically this is where we could do like any like code execution. Could we do like a system call or something? Count.exe. Would that work? Okay, that means on this side, if we want to okay, if we do 1337, could we do it all in one command? 1338 and then 1339. So it recognized 38, 39, or 37, 38, but it didn't look like it saw 39. There you go. Oh, execute a calc. There you go. Okay, it doesn't, it just looks like that isn't sequential. Okay. Wow, chat is insane. Like, it's crazy how chat just built this, pretty much this whole thing. I just don't want to like leave it here. Like, I just want to learn a little bit more. So if you want to actually establish the WinSock, yeah, let me rewrite the code base basically, just so I know that I know what it's doing, you know? Okay, and then, yeah, so like here, I would do socket, sock, and then 14 delete, and then our struct socker in socket adder, socket client adder. Okay. In address length. size of client editor. Buffer. Sequence index. Okay, and then server editor, blah, blah, blah. Okay, I put that down here. Okay, so in terms of server editor.synth family, yeah, we create that here. And then address length. Okay. Well, yeah, I mean, yeah, we got it working. We just got it working way quicker than I was anticipating. Whoops. Create sequence detected. Change in brackets, plus sign. Executing action, and then we're just doing calc.exe. Now we could have it reach back, right? But then we'd have to build out a socket server on the Linux side. But yeah, if you wanted to do port knocking, it looks like UDP is the best way to go. Chasm plays. Hey, what's up? What's going on? Yeah, I was playing around with the idea of port knocking, which is the ability for a target piece of malware to communicate with the attacker machine by the attacker hitting a series of ports on the computer. And once those ports are recognized, then the target will establish some sort of a connection or execute code or do something. So we got it working now. But yeah, it looks like it's basic Windows socket stuff. I think I would like to rebuild this at some time. Actually learn a little bit more about like the Windows socket stuff and like what these what these parts of the code are doing, I guess. Okay, should I rebuild it? I guess I could. Maybe I will. Because I feel like I don't feel like I've learned anything. You know what I mean? Alright, we'll call this port knocker.c. No. Port knocker.c. Okay. So I'll include my usual standard input output.h, standard lib.h. We need to include WinSocket2. Is that what it is? WinSocket2? Or WinSock2. Okay. WinSock2.h. Then include Windows.h. Okay, why is there no suggestions coming in for like we have like C stuff. Do we need clean maybe? Clean D. All right, yeah, let's install this. Reload window. All right, so hopefully that should like recognize code I'm trying to write. There you go. Okay. Cool. So I know I want to define our number of ports to 3. All right, and then we'll actually start developing the main in here. So int main, what we'll probably do is, well, first of all, return exit success. Okay. And then on top of that, we'll call our listener. Okay. And then we'll just do void listener. And this is where we will do the listening. So we'll listen for knocked ports. Okay. So at this point, we need to create our port array. So we'll just do int port array equals 1337, 1338, and 1339. Okay, cool. Num ports. Cool. All right, what's next? So now we need to actually create our socket. So now that we know it's possible, let's see if we can actually learn how to make these like, okay, so let's just start with WSA startup right here. And just paste that in here. Okay. So let's see if we can get this. Oh, this is 4 spit here. Can we use tab size of 2? That's what I'm used to. Wait, why aren't you working? Spaces. Indent using spaces. Use 2. There you go. Okay, there you go. Why is it complaining? Okay, anyway. Did we make our listener void in here? Yeah, we did. Okay. We'll just do a return, just like a blank return. I don't know why this is complaining. Undeclared function listener. Oh, I mean like, do we need to do that? Like void listener void, and then in here void I mean, technically, I'm not making a header file for this, so. Prototypes. Okay, so we created our array of ports. We have our main code, and then, all right, so far so good. I actually don't know why this is still red. Listener. Oh, I misspelled it. Listener. I think that's how you spell listener. Yeah. I was wondering why it was red. There you go. All right, cool. Gotta go. It's nice to see you uploading again. Appreciate it. Oh yeah, catch you. All right, so we created our prototype for the listener, and then we have our, I'll just put globals. Cool. And then here's the main code, right? We're just calling it the listener, and we exit for now. All right, and then we're just going to do WSA startup. So let's look at the documentation and let's see what WSA startup returns, its type, whatever. So return value, it returns 0, otherwise an error occurred. Okay, so that means in our main code, we're just checking for 0, right? Yeah, not equals 0. Makes sense, okay. So if all this is not equal to 0, okay, so we need word version required, and I think that's where we use the dword 2,2. And then, oh, it's make word, excuse me. So change to W, make word. So what's that make word function do? I just want to get a little familiar with like, what is make word? Macro used in WinSockets to specify the version. So this is, okay, version 2.2. Gotcha. Let me look at the, no, this is not what I'm looking for. Where's the, oh yeah, this is the socket function. Yeah, that's what I'm looking for. Got you. A pointer to WS data. Okay, so that means we need to create that WS data long pointer to WS data. So here we'll do our WS data, and we'll just call it WSA. Or not WS data, WSA data. That means we just put the address of WSA in here. Okay, there you go. Cool. And then that means if this fails, so fprintf, can we do fprintf in here? Like, is there a standard error? I mean, that's a Linux thing, you know. But I don't know. I haven't done this on Windows before, so I don't know if this is going to also be a Windows thing or not. Standard error, and then we'll just do error. Okay. And then that means we couldn't start up WSA. Okay, got you. So I'll just do WSA startup failed. And then we'll do the get last error. But there's actually a WSA get last error. Yeah. and that's what we'll use. We need to do a %d new line. Okay. So that looks good so far. All right, so here, start up WSA. All right, nice. So what's the next thing we need to do? Actually create our socket. Yeah, so we need to actually create our socket. So socket, let's call it sock equals, how do we do this? The socket function, okay. So if I actually look at the docs, where is WSA startup in all this? Startup function, got you, okay. All right, socket, so we'll do our socket function, and then we're gonna need to do AF inet for IPv4. We want the UDP type. So it's not IP proto UDP because that's the protocol. It's here. Let me actually look at the socket Windows. Right. So we're looking for the type. Sock stream, sock dgram. Okay, that's what it is. So I know I could have just looked on the other code, but I'm actually trying to like learn some of the stuff. Dgram. Okay. And then now we can use IP proto UDP. Cool. So now we need to be able to check to see if there was an error making that socket. So now we're going to check to see what the return value is. If no error occurs, the socket returns a new descriptor referring to new socket. Otherwise, a value of invalid socket is returned. So if we check to see if it's an invalid socket, we will know. So if sock equals invalid socket, we know there was an error. So we can do, also we can do return exit failure up here. Oh yeah, interesting. So because this is a void, we actually can't return exit failure. So I'm going to make this an int, and then we're down here, int. So that way we can make sure that the listener ran successfully. So in fact, we'll do if listener not equal to 0, fprintf standard error, error listener failed to run. And then I'll do this %d /n, and then we'll just do a get last error, and then we can do return exit failure. Why is this complaining? Preference D word. So do we need LD? Okay. There you go. So here we'll do attempt to run listener. And in fact, we'll do printf. Actually, well, yeah, I mean, we can do that in the main if we want to. Doesn't really matter. So socket AF net sock string user blah 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 sock equals invalid socket. So that means we're doing f printf, and then we'll do standard error, then we'll do error, and then here we'll say socket failed %d new line, and then we'll do WSA. So is this a WSA get last error, or would this just be a normal get last error? Because it is WSA. Okay, so because socket is part of the Windows socket library. That makes sense. Okay. What the hell is going on? There you go. And then now that means we can go ahead and return exit failure. Cool. So yeah, this will actually create the socket. Okay, so when we create a socket, what is next? What do we, oh, so now we can return exit success. Cool. So in our, why is port knocker still erroring? What? Get rid of that. I don't want that. Okay. Anyway, that's what I don't like about VS Code. It just adds. Is that C++? No, this is C. Okay. So after we created the socket, we need to bind the socket to available interfaces. Okay. So the next step is to bind socket to interfaces. So how do we actually do that, right? How long did it take you to learn? And what would you recommend? Would you recommend me to learn it? I also want to learn C++. If you're new, learn C++, and then most of the stuff will translate over to C. I think it'll make the process easier to learn, because I think C++ handles a little bit more for you that you don't have to worry about as much. And then it will give you a good understanding of the syntax that C uses, and then you can pivot from C++ to C. That would be my, if you're new, that would be my recommendation. If you have programming experience already, then you can just go straight into C. Okay. So how do we bind? Like, yeah, how would I know to use the bind stuff? Is there a bind? Bind function in WinSock. Int bind, a pointer to the sock adder structure. Okay, let's look at this. How long did it take you to actually master it? I don't know. Maybe let's say if you're programming with it like every day, every other day, you can pick it up in a few months, like fully. To like, I don't know if you'll ever master a language, but to be proficient, probably after like 4 or 5 months, you'll be like proficient. I don't know. Even after, I guess it depends how much you're programming. Like if you're doing like a project, or if you're doing something like like leak code or something similar. Maybe not leak code, because I know the questions could be a little bit more complex at times. But like if you're doing something similar to that in programming regularly, you can pick it up within like 2-3 months. But like just to get like the basics down, you can pick that up in like a day. Okay, so let's look at. So what I do is we have our struct of type soccer add-in. And then we do a soccer adder and our client adder. Where do we use client adder? Interesting. Okay, I guess we'll get there when we get there. So struct sock adder in. Okay, and then we do our our client. So the server address and the client address. Oh, because we are the server, right? And then the client is the attacker machine. That's so weird to think about. I don't know, my brain doesn't think of it like that. Oops. Keep hitting my mic. All right, so struct soccer add in, and then we'll do the. I might call it target instead of server. Yeah, target, adder, attacker, adder. I think that's going to help me think about it. So now we're going to do our target adder dot sin adder, and that's going to be equal to AF inet. No, maybe it's not sin adder. It's sin family is AF inet. Okay. AF inet. Trying to learn how to make games on Android and all that stuff. Also like hack stuff. Yeah, if you're trying to make games on, well, actually I don't know too much about Android, but I know like Java and Kotlin are pretty popular. So those are probably the languages you would want to learn, I think. But you probably have to do some more research into that. All right, let me actually understand what the soccer adder thing is. So sock adder. Structure varies depending on the protocol selected, except for the blah, 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 one sock, blah, blah, blah. Okay, so it depends on... Okay, so we're using soccer adder in. So what's the difference between these two? Let's say family. Oh, so this specifies things like the port. Okay, I'm gonna have chat teach me about these. Okay, these are structs used in WinSock. So sock adder, generic socket address structure, right? The purpose is to act as a general structure for storing different types of socket addresses. When a function needs to handle both IPv4 and IPv6 addresses without knowing which in advance, you usually cast a more specific structure, like into adder, when calling functions like bind or socket. Interesting. So you'll cast a specific one, like in. So in is specifically for IPv4. Okay. Got you. So that means there's probably one for IPv6 and stuff. Got you. Good luck with the stream. Appreciate it, man. Okay, so the family would be FINet. Oh, wait. So IPv4 specific? Huh. So the family is IPv4 or AFINet, right? That's what we specified. Then we can specify the port, the adder. So why is there a adder? Convert. Oh, really? INET adder. You convert the IP string into binary. Is that what that is? Interesting. Okay, how to use the WinSock. Yeah, so when you, since bind and connect expect a struct of sock adder, you can cast sock adder into sock adder. So that's what you're doing here. You're casting your server address, which is of type sock in, to your sock address. Got you. Okay, I think I have a better grasp of what that's doing. So we have family for this, and then we have target address dot sign, I think sign adder, and then this is going to be what, sock dgram. That S adder. Wait, what? wait. Where was that in the docs? Oh, it's another struct. What struct is this in adder? Okay, tell me about this struct. The SYN adder field inside struct sock adder is used to store an IPv4 address in binary format. Did it talk about that? The sign ADDR. Let me see if I can find that specific struct. Is that in here? And if in address sign ADDR. Example socket. Interesting. So sign adder dot s adder. Server blah 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 HTTP tons blah blah blah. Okay. Whoops. Okay. So how do we do it in our original program? We do in adder any. What does that resolve to? Macro is a ulon that expands to 0, an unsigned lon of 0. Oh, is that for 0.0.0.0? Is that what that's doing? No way. That is cool. Because it needs to be in like binary. Is this resolved to 0.0.0.0? Wow. Or you can, so you could do INET adder 0.0.0.0. The name? What's up? What's up, the name? How you doing? This is equivalent to 0.0. This binds the socket to all available interfaces. The server accepts. Got you. That is cool. I did not realize that at all. All right, so in adder any. Okay, so now we've binded everything to the socket interfaces. Amazing. Hey, I love that. Amazing. You're doing amazing. That's great. Don't ever stop. String. Oh yeah, we don't need string. We can delete that. So now this is when we actually start listening to the ports. All right, so start listening to not ports. All right, so this will do a printf, and then we'll do our plus sign listening to ports. Okay, so here listen for UDP port knocks on %d. Yeah. Listening for knocks on. Okay, we'll do %d, and then %d, /n. Okay. First of all, we need to make this a asterisk, and then here we do our port array of index 0, port array of index 1, and then port array of index 2. Okay. You know, VS Code is cool and all, but sometimes this stuff can get really annoying. Like, I don't know why that format thing is throwing me off my indenting. Okay, so now we're listening for those port knocks. All right, what's next? After that, this is where we start to do the loop and start waiting for each one. So while one iterate through each port on success. Okay. So what are we doing after that? Our server address, which is our target address signed port. Oh, it's because we're changing the port each time we want to be part of the loop. Okay, that makes sense. So we'll do our target address and then our sign port, and that's going to be equal to, so how do we actually assign the ports? We do htons. So what's htons? H2 in computing anyness is the order in which bytes within a word. Okay, well no, I just need to know what's the H? Handle to something? Converts the unsigned converts an unsigned short integer. Wait, converts the unsigned short integer host short from a host byte order to a network byte order. Oh, that's right, because network byte orders are like different, right? Interesting. Okay, so this converts the byte order. See, like, yeah, this is why I didn't just want to like stay with the one we generated. Like, I actually wanted to go through this stuff and understand what was, you know, happening and working through this code, which I encourage all of you to do. So to convert that port number, then we can just do so we're doing a while loop. In my eyes, we should be doing a for loop. So for int I equals 0, I is less than num ports, I plus plus. I mean, this is how I would program it, you know. And then now we would do our port array on index I. There you go. So that would get the port and convert it in the proper byte order. How did we do it here? Yeah, it created a sequence index. Yeah, see, that's cool and all, but I'm good. Okay. So now we'll do our bind function. Now, bind, we need our socket. So we have our sock. Then we have a constant to the struct adder star name. Okay, so that would be our target address, but we need to typecast it, right? So we need to cast it to a struct of sock adder star, and then in here we would put our target adder. That's not right. Okay. Oh, do we need the address of? Okay, let's see if I was able to get that right. Struct sock adder star, and then yeah, okay, that is right. So it's because it wants that type in bind, right? If we actually look at the documentation for bind, so if we do bind windows bind function. So yeah, it wants a constant sock adder, and we're having sock adder in our code. Got you. Okay. And then the last thing is the name length. What the hell is that third parameter supposed to be? Int name length. Let's see what this is. The length in bytes of the value pointed to by adder. So size of, right? Would that be some sort of size of? Size of the address. Gotcha. Okay, got you. So size of the target address. Okay, and it's complaining, right? If we need to compare this to something. Okay, so what's the return value on bind? If no error occurs, it returns 0. Otherwise, it returns socket error. So if it's equal to socket error. Equals socket error. Okay. A COC, it's a local address with a socket, right? Yeah. Okay, so here we actually bind the socket, and then here we specify port. Okay, so we're specifying the port, then we actually bind the socket. So if it's equal to socket error, then it errors. So we know that we can do a fprintf, and then we will do standard error And then we'll do, wait, okay, because I'm used to Linux programming C on Linux and not Windows as much. So is fprint f to standard error good practice on Windows? Yes, it's generally good practice on Windows, just like Unix has. There's some caveats depending on your use case. For console applications, it prints immediately without buffering. Gotcha. Right, because it's unbuffered. Okay, cool. That's all I need to hear. As long as I know it's good practice, I'll keep doing it. After that, we know that it errored, so we can do this, and then error bind failed %d /n, and then we can do our WSA get last error, and then after that we can return exit fail. All right, cool. So after we bind the socket, we can, so after we bind the socket, there's more than we actually have to do, because it looks like we get less error. We actually have to close the socket and do a cleanup. Okay, so that's good to know. Right, because we actually have the socket open now. So we'll do WSA cleanup, and then what was the other one? Close socket. Close socket, and sock is the name of our socket. Okay, so now we have to wait for the UDP packet. And that's a receive from. So I'm wondering, like, outside of the normal Win2, what exactly is WSA? Windows sockets. What exactly is WSA? Okay, Windows Socket API. Okay, so it's the API for Waken sockets in Windows. Okay, that makes sense. Okay, so we've done pretty much everything up until the point where we actually have to, so wait for UDP knock. So this is where we do the receive from stuff. Let me see if I could find it myself in the, there you go, receive from. Okay, in our original code, we did use receive from. Okay, so let's go ahead and just copy this, and then we'll build it out. So we know that it's going to return the int type. So first it wants the socket, so that's going to be sock, and then it's going to want the character buffer. So what is this buffer for? A buffer for the incoming data. Okay, so do we have to create a, well, we don't really care what the data is. We just need to we just need to know that the knock happened. So we just need a throwaway buffer basically. Okay, so a new one isn't created on each loop. We'll create our character buffer right here. So char star buffer. But how big do we want it to be? Is there a specified size? Let me look at what we did in the original program. So in here, where we did receive from, we did to our buffer, and buffer, oh, literally size of 1. Okay. Right, because again, we don't really care about the content that's coming through. Okay, so we can just do, we'll just call it buffer, and we'll give it a size of 1 as well. And then in here, we'll do buffer. Okay. And then after that, it's asking for the length. Is that the length of the buffer? Is that just size of buffer? Or is it asking for something specific? Length in bytes of the buffer pointed. Okay, perfect. And then flags. I set options that modify the behavior of the function call. What flags do we have? I don't see. Can we just put that as null or 0? Do we care? Let's check what we did here. Yeah, flags. Okay, so we just set a 0. Okay, makes sense. Yep. So we do 0 here as well. We can get rid of length. We can get flags, and then sock address from. So this is where we implement the attacker address, right? Because this is where we care. It's coming from the attacker now. So receive from sock address start client. Yeah. So this is where we care about the attacker address. So we can do struct sock adder star, and then we want the address of the attacker address, and then we want size of the attacker address, and then is that it? If size of incompatible. Is that not what it wants? And address length. Okay, let me actually read the documentation. Because and then from length, an optional pointer to the size and bytes of the buffer pointed to by the from parameter. Okay. All right, let's have chat teach me more about what this is doing. In the meantime, so the size of this. So what did we do here? What did it want? So we did ADDR length. So that's the size of the client address. Wait, that's what I did. Size of client address. Size of the attacker address. Incompatible conversion. Oh, do we need to typecast it? Hi, I just joined. What's the topic of the live? Yeah, I should update the title. We're doing port knocking. It's some malware development stuff. Just as a quick review, I know people who've been watching kind of understand, but we have an attacker machine and a target machine, and basically we are sending a series of ports, like traffic to a series of ports that actually aren't open on the target. Well, technically they are open, but they're open under UDP instead of TCP, so it doesn't pop up on like netstat or anything like that. But yeah, we can basically hit those ports, and then the malware listening on the computer can recognize that the attacker's trying to talk to us, and then it'll establish a connection. So it's kind of like a secret passcode, if you will, between the attacker and target to establish a connection. It's a tactic that I've heard of, but I never actually done anything with it before. So I wanted to learn how to do it. It's been a good learning experience so far. Basically, reverse shell. Basically, yeah. But the only difference here is that we want to establish the connection by running a series of ports. Actually, I'll show you. I'll show you a quick demo, right? If I, all right, hopefully that's big enough. So if I run the listener right now, you can see that it's listening for any knocks on port 1337, 38, and then 39. So on our attacker computer, right, we can do a knock on, right, we can send a packet at port 1337 to that computer. You'll see that it detected that UDP knock, right? So then we can go ahead and we'll do 38, and you can see that, and then it'll do 39, and then it spawned calculator because it was able to recognize that it did that that connection. So that's kind of the goal here, right? It was able to recognize that we sent packets from this target machine or attacker machine to the target, and then started executing something. It's not necessarily like a shell per se. It's just that tactic to initialize execution between two computers. Right, so instead of just like the malware running and then it immediately reaches out to the internet to do something, we can kind of just have it lay stagnant, and then we can send a series of, I guess, traffic to these ports to enable a connection. So we receive from, okay, why does that not work? Okay, I think we need to typecast it to, I'm gonna do an int. No. Because it doesn't work like this, right? But if we do int, I'll just do int s equals size of this thing, and then we do s. It doesn't, does it complain? I can't tell if it's complaining. Oh, the extra parentheses. Expected a semicolon. Oh, whoops. No, it's still complaining. What type did we make this here? Int address length equals the size of the client address. Yeah, to prevent it from calling out every 5 minutes or anything, we can just wait for a signal. Yeah, that's a way better way of explaining it. Yeah, that's a way better way of explaining it. Thank you. Int s equals size of, wait, what is it complaining about here? Incompatible integer to pointer, parsing int to parameter, type of int, of int star. Oh, really? Did we do that down here too? Address of the address length. What? Okay, that that confused the hell out of me. Okay, yeah, I see we're saving it to that space, but okay. Anyway, okay, let's keep going. Just our buffer right there, and then so this is going to be the address length then. Length. And I don't want to declare it on each loop for stack space, so we will put that up here as well. Nope, that's not what I meant to do. Okay. So if all this is, okay, well, first of all, it's no longer S, it's address length. And then if that is equal to a socket error, I'm assuming. I actually didn't look at the return value, so I don't know for sure. Return value, yeah, socket error if it's returned. Okay, cool. So if it returns socket error, we know something went wrong, so we can do fprintf. Standard error. Error. Okay. The receive from receive failed. All right, %d \n. And in here, we're just going to do WSA, get last error. All right, and then I'm assuming we also need to close the socket here. And actually, do we? I don't think we need to close the socket. So if it's not equal to socket error, oh, I see. If it's not equal to socket error, then it's going to say, hey, we did some stuff. And that's going to increment. Okay, I see why I chose to do a while loop now. Fail to receive UDP packet. Okay, so this is what we do. So if it's not equal to a socket error, so this will be our else. So exception, failed receive. All right, and then we can do a printf. Plus sign, success. I know how you spell success. Success. That does not look right. Is it two C's? I don't know why this looks so weird all of a sudden. I'm probably spelling that wrong. I can't believe I'm Googling how to spell success right now. Oh, it is two S's. I mean, two C's. That's what I meant. Okay, cool. I was not tripping. I was right the whole time. Okay. Anyway, success. Detected. UDP knock on port %d. \n. And then this should be array, port array at index I. So yeah, if listener fails, try and exit failure. Otherwise, we'll just do let's call it proof of concept. Actually, yeah, how about this? We'll call this we'll call this command parser. And then in here, we'll just put like calc.exe. And then we'll do void cmd parser, and then we'll do a char star command. And then right here, we'll call this command. Instead of command parser, let's do cmd exec. Okay, cool. And then in here, we'll just do something like system. This is kind of overkill, actually, if I'm being if I'm being entirely honest. Whoops. Yeah, we don't need a command executor. We can just system this. Yeah. Okay. Execute malware, right? So this is like the proof of concept part, you know. Okay, cool. So that's how it would work in the real world. Okay, cool. So going back to the actual listener. So success detected UDP on that port. Else we're going to receive. Yeah. And is that it? I think we had to close the socket. So unbind the port stealthily. I love how that's in parentheses. All right, so then we unbind. And then sock equals, oh, and then re-initialize what socket is equal to. Interesting. Okay. So at the end of this process, well, if it failed to receive, yeah, if it failed to receive, is it just gonna, oh, so it only increments the index if it needs to. Okay. I mean, technically we could just do like a I minus minus in here and call it a day. Right? I don't know. We'll figure it out. So detected on the knock. So once if it is detected, that's when we update the socket. Okay, so this is where we would do, this is where we would close the socket. So close socket, sock, and then this is where we would create the new socket. So sock equals sockets AF inet. No, that's not what I was trying to type. AF inet. The type should be, always forget this. What is it? It's like something dgram. It's something dgram. Sock dgram. That's what it is. Sock dgram. And then it changed to this. And then this is what the IP proto UDP. So that updates what our sock is. So then when we go back up here, right, where did we create our sock way up there. Okay, cool. Oh, this is error prone because it keeps failing. Maybe this shouldn't be. Close socket, blah, blah, blah. And then this is the cleanup, right? So close socket, and then WSET cleanup. Okay, that makes sense. So we'll just add that stuff in here. So close socket sock, .t, and then WSA cleanup. And this is our clean. And exit. Well, actually, no, we don't want this to be part of the for loop. We want this to be afterwards. Yeah. How much longer? We're pretty close to finishing, but we're not done yet, so you have some time. Oh, why is there a C there? Standard IO.h. Okay. Let's complain about buffer here. Incompatible types, passing char star 1. Oh, did I make it a char star? Should just be char buffer 1. Yeah, there you go. Okay. So the only thing we need to figure out now is if we get an error on the next loop, it's going to iterate again. Yeah, so I guess we don't want a for loop. Can we do a do while? Change to int I equals 0. And then here will be our while I is less than num ports. Like that. And then basically if it does receive, we'll do an I++. Okay. And then that should work. Okay. I guess we don't know until oh, let's let it know we got the correct sequence. If I is equal to num ports, we'll just do a printf success, correct, sequence detected. Okay, and then now we can do a \n. All right, and then this will be for correct sequence. I mean, technically that's when we could do the system stuff here too. So I'll just put like a note could run proof of concept here, but we don't really have to. But that should work. Whoops, I did not mean to run Visual Studio. Close, close, close. Close. Whoops. Okay. So now if we do GCC on our port knocker, tech O knocker.exe, and then we do tech. Oh wait, we didn't do our pragma. You'll cost me. Do I need a crypter? I'll take one, sure. I don't know if I need one. All right, yeah. Let me actually better understand what this is doing. Okay, so what did we put in here earlier? Oh yeah, the receive from. Okay, yeah, I wanted to understand this better too. So receive from in a socket is used to receive data from a socket, okay, particularly for UDP connectionless sockets. Okay. Socket descriptor, the buffer, blah, 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 flag, sender's address for the output, and then size of, oh, I see, so that's where we're saving it to. Okay, makes sense, makes sense. We don't really need the example. We have an example. Gotcha. Okay. And then we can use WSA to check errors. Okay. And then this is a compiler directive to tell MVS to automatically link the WinSock library. Okay, but it didn't do that. Oh, that's for like Clang. So that's supposed to work, but it didn't. Like we are supposed to be able to have this here. So I shouldn't actually need to link anything. Yeah. I added this, but still get a linking error to add tech LWS32. That's what the compiling flag is, right? Yeah, tech LWS2 underscore 32. WS2 underscore. Oh, it doesn't work with GCC. Oh. Gotcha. Why it doesn't work in MinW? Oh, so you need to use Clang or something? Okay, that's cool. Which means we don't need this then because we're using GCC. Okay, so here's the final test. We should be able to, oh, we need to add tech L WS2 underscore 32. Clear. If we run knocker.exe, we will allow. I don't like that space after the 39. Okay, so if we go up to okay, yeah, this should work. So if we go to our terminal, let's just clear and then run Docker. All right, cool. So now we're listening. If we go to our terminal and we run 37, okay, 38, and then 39, and then look over here, boom, it's spawn calculator. Okay, perfect. Wow, that is sick. Let me do a quick error check just to make sure everything is working. Okay, so let's just run this again. All right, so let's say if we do like, let's do 38 first. Oh, nothing. Okay, perfect. So now we'll do 37 first. And does this still work? Yep, 37. 38. What am I doing? We're doing, that has to be the most asked question this so far. We're doing some light malware development. More specifically, we're doing we're testing out a technique of something called port knocking, which is where we can send a series of packets to a target machine to initiate a connection between us, or to initiate some sort of code execution rather than having it continuously call out to us. And yeah, it ran calculator. That is sick. Okay, I actually learned so much. I haven't used WinSocket before. I've only done like normal like TCP stuff. So this has actually been a really good learning experience for me to actually build something like this. And just for people who kind of got lost in the sauce of the programming, I guess I can go over the code real quick just so you guys have an understanding. So obviously we have the pretty standard include stuff, but we also have WinSock for the Windows sockets, and then the actual Windows API stuff as well. And then we have a macro here for the number of ports we want to have in our combination. So got it. So you're worth it to subscribe. I appreciate that. Thank you. So we're going to have 3 ports that we're going to check. We're going to have 13, 37, 38, and 39. We declare our listener right here for our prototype that we'll use later. And then we have our global array for the ports that we will be listening on, which is 13, 37, 38, and 39. Okay, cool. So in our main function, we actually run our listener. And if it is not, the listener is not equal to 0, which means it failed. In fact, we can even do like an exit success here. Like if the listener didn't exit successfully, then, because this expands to 0, right? Yeah, okay, cool. If the listener didn't exit successfully, then we'll let the user know that it failed, and we can exit with failure. If that means assuming it ran successfully, then we'll run calc.exe. Now for our actual listener, we actually don't need to have wdata.sa up there. We can do that in here. In fact, actually, I'll put it right here for better practice. Okay, cool. So in our listener, we are setting up our Windows socket right here. We start up the Windows socket API, and then we create the socket, and we're using IPv4, which is what AFINet is, and then our address family IPv4. We're using UDP, which is why it's a socket datagram, right? User datagram protocol, UDP. And then we're specifying the protocol to be UDP. So this is the type of socket, and this is the protocol that the socket uses. If the sock is, if the sock's invalid, it'll let it know that there's an error. Otherwise, we'll keep going. So now we actually bind the socket to the interfaces, right? So we're actually binding the socket we created to IPv4, and then we're specifying our target address to be any all hosts. Like we're listening on 0.0.0.0. That's what this expands to. Like if I hover this, it should expand to, there you go. It expands to a bunch of zeros, which is 0.0.0.0. In here, I'll add that as a comment here. 0.0.0.0.0. Right, so we're listening for all hosts. All right, cool. And then after that, we let the user know that we're listening to those 3 ports. What ID is this? Oh yeah, I'm using Codium. Visual Studio Codium. Yeah, it's just VS Code. It's basically VS Code. Yeah, it's just open source. Okay, cool. So after that, we set up our character buffer and our address length that we will need later on. And then we're doing a do while loop, right? We're saying I equal to 0, and then we're going to do this as long as our I is less than the number of ports. So then we go ahead and attach basically bind a port to the socket we created, and we're binding the first port in our port array. After that, we bind the socket with the bind function, and if that fails, we'll let the user know that the bind failed, and then we'll close the socket and do a cleanup. Now, at this point, the socket is built, so we can just wait for any UDP traffic to hit our machine. So we'll do a receive from, which will basically wait to receive from any, UDP traffic that hits us. So cyber nerds use Codium? No, I mostly use NeoVim, but because I'm on Windows, I'm just using Pornocker. We actually could probably install NeoVim while we're here. Installing updates, cool. Yeah, it's going to be a little bit slower because I'm streaming right now. I'll do it later. I'll do it in my own time. I'll do it in my own time. So we'll wait for the UDP knock, and then basically, assuming that we get the receive from and it's not an error, we will let them know that we got a successful knock from the target machine, or the attacker machine. Actually, could we specify the from address? We probably could, because that should be saved to the attacker adder. Yeah. So I'll look into that later. But yeah, if the I is equal to the number of ports, that means it's a full success. And we could run the proof of concept there if we wanted to, but we don't really need to. And then after that, we'll update the socket with the new port, so that way we can continue the process. Cool. Otherwise, we'll let them know that the receive failed, and then it will continue going through the loop. And yeah, and then we'll just clean up and close. And then that would take you back to the main function where we execute calc.exe. So that's the overview. I mean, now that we know that we're done, I want to actually see if we can print the address. So on port %d from %, oh god, okay. So like in the original listener.c, can I tell you why I'm using Codium instead of VS Code or other IDEs? Yeah. I guess the TLDR is that Codium is open source. It's a little bit lighter. I think a little bit more lightweight. I feel like Visual Studio is just a little bit more bloated. In terms of Windows development, I think it's just like an easy, simple one. I don't really have to worry too much about like privacy issues or anything like that. I still do use Visual Studio. Yeah, Visual Studio, the purple one. If I'm like working through like something heavier, or like if I'm working through any of the courses I'm taking, like Maldev Academy, they use Visual Studio as their main editor. So just so I don't have to like keep translating stuff over, I'll also use Visual Studio. But there's no particular reason besides that, my main editor of choice is NeoVim, which I use way more often because I'm just on the Linux side more often. And in fact, I probably will end up installing NeoVim on my Windows virtual machine. So honestly, just pick an editor that works for you. I don't think it truly matters as long as you know your editor, right? Your editor is supposed to serve you, it's supposed to help you make more efficient like coding choices and automate a lot of simple things for you. So as long as it's not a headache, it's something that you're comfortable with. I think that's all that truly matters. So that's my opinion. I want to see if we can print the address. So in the listener.c, we save the receive from client address. Can we print out the client IP address? Got it, yeah. So in the soccer address structure, received from %s. So you can do inet to A, which I'm assuming that's IPv4 to ASCII. Well, I don't really care about the buffer. I care about this. So inet to A. Let's look at that function. Inet to A. Okay, where is inet? Bro, there's inet ONT to A. Okay. Okay, the function converts the internet host given by network order to a string in IPv4 decimal notation. Okay, got you. So in our port knocker, we can do %s here, and then actually in this, let's go ahead and that means we can do inet _nt to A, and then we can pass in the client adder dot sign adder. So in this case, this would be the attacker adder dot sign adder. Call to undeclared function. Oh, is that too many T's? Whoops. inet nt to A is deprecated. Use inet and net to P. Okay. inet to P. What was it? I forgot what was the function I wanted to use again. Hello. inet and top. Okay. inet and top. Call to undeclared function inet. Oh, did I do int? Whoops. inet and top. Is this like a different function? Okay. So inet to A is deprecated. I was told to use inet and to P. inet to A is considered unsafe, really, because it returns a static buffer that can be overridden. Interesting. Okay, yeah, you don't have to rewrite this entire code base for me. You can just tell me how to use it, like from client IP. Dude, TLDR, just give me the code. TLDR, just show me how to use the function. Show me how to use the function. Here's the correct way to use inet top and one side. Dude, I just said just the... Oh, Jesus Christ. That's the whole thing? inet ntop, AFINet, the address of that, the client IP. Oh my gosh. Okay. That's a lot just to just to okay. This is like a lot, but it's all right. Honestly, can I just use the deprecated function? I might just use that. This is a proof of concept anyway, guys. You know what I'm saying? Like, we don't need to be secure with our programming. /docker. Okay, yeah, so let's see if I reach out to it now. Let's do 1337. Right, and then if we check on the Windows side, yeah, so you can see the IP address that reached out to us. Okay, that's cool. Okay, so yeah, there you go, guys. I mean, we can finish this off real quick. 1338, and then 1339. And if we check, yep. It received those, wow. Okay. Well, that's pretty much all I wanted to do today. So yeah, I definitely appreciate you guys for joining on the stream. Hopefully this was something kind of cool. This is something I have never played with before. So kind of figured it'd be a good learning experience for us to kind of dive through the C code a little bit, learn about how WSA works. Now I understand a little bit more about this stuff, so I feel like I can, I don't know, build some better projects or something with that. But hopefully this was good for you guys. Make sure to leave a like, subscribe, and yeah, have a good day. Stay happy, stay positive, happy hacking. If you enjoy content like this, then you will absolutely love the Happy Hacker site plan. For just $7 a month, you get access to exclusive videos, articles, courses, and learning resources, all created just for you.
But wait, there's more.
You'll also be able to freely access our custom-built malware, tools, payloads, and suites. So if you're ready to level up from a newbie to a pro, head over to cosmodiumcs.com/support and check it out today.